Today's lesson will be adding topic 2.4 to the notebook, in addition to some you-try problems for you to do. So please add these 2 pages to your table of contents. So yesterday we used Desmos.com to graph all of the following equations, and hopefully you noticed some relationships and patterns that started happening with the equations that were proportional versus the equations that weren't. So yesterday you were supposed to sort these 3 equations into the proportional equations. This one we did together, these 2 were on the worksheet. And then over here, the not proportional equations were these 4 equations. We did this one together, and then these 3 were on your worksheet. So what you should be thinking is the not proportional equations have things that the proportional equations do not. And the things that these equations have cause them to not be proportional. For example, here, when we have a +7, this +7 causes the graph not to cross the origin. It will be crossing at 7 on the y-axis instead of 0, 0. Versus this equation over here does not have a plus or a minus anything. This equation here, the -1 causes it to not be proportional because even though it's a straight line, this will cause it to not go through the origin. The fractions are fine. You can have fractions, you can have a whole number, but the key thing for a proportional equation is you have y equals our constant of proportionality and then x. Y equals that constant number and then x. Over here, both of these were not straight lines, even though they both went through the origin. So this one created a U shape. This one created a cubic, which is like an S shape. Sideways, and therefore not proportional. And so that exponent, over here we technically have exponents of 1 because we don't see the exponent, so we just have an x. These exponents cause the graph to not be straight and therefore not proportional. Okay, we're going to be on to your notes sheet on page 25. These 2 have been pre-done for you, except for this one is missing the value in front of the x. So highlighting, I would highlight that all of the constant of proportionality values are the same as the number in front of the x. So this coefficient of x, that's the number in front of x, is the constant of proportionality. And then here on the bottom part of the front of the notes, the question is what goes here. And hopefully you're thinking this value because yes, that is what goes here, except for we would just write a 2. We don't usually put it over 1 because 2 over 1 is just equal to 2. So right here you should be writing a 2. And continuing on, still looking, these are the 2 that were on the front of your note sheet. So other things you could be noticing, if you go here on the graph, you go up 1, right 3, up 1, right 3, up 1, right 3. That's because this tells us the change in our y-axis to our x-axis, the change that goes up and right. And so on this one, we're noticing that these values match the coefficient of x, the number in front of x. And also, if you go up to right 1, we'll be back at the graph, up to right 1, up to right 1, up to right 1. So the change in the steepness of this line is 2 over 1. These are not on the notes page, but there's some additional examples just to see what you notice. So where do these equations come from? So if you look at the graph here, our y over x is 18 divided by 3 or 36 divided by 6. No matter which y over x you do, when you divide, you're going to get 6. So it's y equals 6x. Here, our y over x is 10 because 30 divided by 3 is 10. So here's the actual visual to go with this graph. 30 divided by 3 is 10. And on this one, 14 divided by 7 is 2. So this coefficient is our constant proportionality because our x value 3, looking back up here, times 10 is 30. 8 times 10 is 80. And back here, 3 times 6 is 18. 6 times 6 is 36. And then over here, 7 times 2, 8 times 2. So looking at our constant of proportionality. Okay, now this is the inside of your notes. So you're back to your notes page. You open it up on the top left. This is what I'd like you to add. We're going to have an equation y equals something times x, because that's our coefficient. So we're going to do our y over x values. We have y over x 81 over 3, which 81 divided by 3 simplifies to 27. That is our constant of proportionality. So please write that in your own handwriting. And therefore the equation is y equals 27x, because 3 times 27 is 81, 4 times 27 is 108, 5 times 27 is 135, and 6 times 27 is 162. 27 times the x value equals y, and that's what this equation tells us. So here we have a graph. So once again, we're going to do y over x, and we're going to get a y equals something x equation. So we have our ordered pair of 7 and 56. So y over x is 56 over 7. Divide and you get 8. That is our constant of proportionality. And so the equation would be y equals 8x. And then to show you, you have your x values times 8 equals the y value. 21 times 8 equals 168. 28 times 8. And so all of these values resulting as a multiple of 8. Okay, you're on the right side, the top of your notes. The equation is going to be given for you this time. Y equals 3x, and I want you to generate your y ordered pairs and then graph them. So what we would do is we would take our x value right here. We're going to take away this x and replace it with a 1. So that means y equals 3x is equivalent to y equals 3 times 1. 1 times 3 is 3. Then for this, and we can graph it, over 1, up 3. And then here, now our x value is 2. 3 times 2 is 6. Graph that one. And then it'll be 3 times 3, which is 9. And the last one will be 4 times 3, which is 12. So over 4 and up 12 will be up here. Connect them with a straight line, and we do want to add an arrow. We need this arrow because this equation, we could keep going forever. We could plug in for x 100. 100 times 3 would be 300. So this arrow says that the graph is going to go on to infinity, because we could also plug a million. We could say x equals a million. A million times 3 is 3 million. So that arrow covers all the ordered pairs we can't write on our graph. So don't forget the arrow. Okay, we're on to the second equation. So bottom right of your notes, it's going to be y equals 1/2 x. So think about what you would do to get the y value. Well, you're going to say that instead of an x here, we're going to have a 2. So it's going to be 1/2 of 2, or 1/2 times 2 over 1. 1/2 of 2 is 1. Also, 1 times 2 is 2. 2 times 1 is 2. 2 divided by 2 is 1. And we graph it over 2 up 1. The next one, half of 4. 1 times 4 is 4. 4 divided by 2 is 2. And then half of 6, which is 3. And half of 8, which would be 4. And you graph it. We connect it with a straight line that goes through the origin. And don't forget your arrow. And now last but not least, on page 26, you're going to put these two you-try problems, and I would like you to try to find the equation based on the table and find the equation based on the graph. So take a moment and try these problems before you see the answer. Pause the video, please. So number 1, you're going to have your y over x value to figure out the constant of proportionality, 26 divided by 10. You could either write it as a fraction, 13 over 5, and an improper fraction is fine. We don't tend to change things to mixed numbers when we're writing equations. And you could also convert it to a decimal. So you could do 26 divided by 10 in the calculator and you'll get 2.6. So therefore our equation could be y equals 13 over 5x, or y equals 2.6x. And for note's sake, let's go ahead and put both of these answers in the notes so you know that these are both equivalent and possible right answers. So on this one, We have our y over x value. So you're going to put y over x. I use the first point here, 2 over 8, which simplifies to 1/4. Or if you use the decimal version, it's going to be 0.25. So therefore, we have two possibilities for the equation. We could have y equals 1/4 x, or we could have y equals 0.25x. And that's it for today's notes.